This is the second video over section 7.3, double integrals over general regions. And so example 208, our region is bounded by these curves. So from x equals 0 to x equals 4, and then from the x-axis up to y equals x squared. This is both a type 1 and a type 2 region. And so we're going to do this two different ways. One is a type 1 and one is a type 2. And so here we're going to set this up as a type 1 region. And so y goes from 0 up to x squared, and x goes from 0 to 4. And so we've set this up as a type 1 region, integrating our function x squared plus xy dy dx. Because our y limits of integration are 0 to a function of x, so we integrate with respect to y first. So we find the antiderivative with respect to y. Again, it's sort of like taking partial derivatives. We just pretend x is a constant. We treat it like a constant. So we have an antiderivative with respect to y of x squared is simply x squared times y. And for this term, we reverse the power rule. So we have 1/2 y squared. Again, we're treating the x as if it's a constant. So we substitute our y limits of integration and subtract. And when we do that, now we have a function of x. So we simply have a 5th degree polynomial. We integrate from 0 to 4, and this is simply a calculus 1 problem. So we find an antiderivative, substitute 4, substitute 0, and subtract. And now we're going to set this up as a type 2 region. Now remember what I said in the last video. Even though both methods are correct and we'll get the same answer both ways, that does not mean that both integrals are equally easy to do. So it could very well be that one of these is simpler than the other. And I think for this particular example, setting it up as a type 1 region was simpler than a type 2. But we can set it up as a type 2. And so in this case, we have y goes from 0 to 16, and of course you'll notice my picture's not to scale. But y goes from 0 to 16, and x goes from square root of y to 4. So we just solved this in terms of x, and so x is square root of y. So x goes from the square root of y to 4. So the x limits of integration, square root of y to 4. The y limits of integration are 0 to 16. We have our same function. We integrate with respect to x first, then y. So we find an antiderivative with respect to x. Here we just have 1/3 x cubed plus 1/2 x squared y. Again, for this part, we're pretending y is a constant. So we're integrating with respect to x. Then we substitute our x limits of integration. We substitute 4. We substitute y, and we subtract. Simplified it a little bit here. And again, we just have a Calc 1 problem. Now you'll notice our Calc 1 problem isn't quite as easy as the Calc 1 problem we had when we were treating it as a type 1. So again, though, we just find an antiderivative with respect to y. We got a little crowded here. So find your antiderivative, substitute 16, substitute 0, subtract. And of course we get the same answer, because this region is both a type 1 and a type 2.